Okay, so in this video, we're going to describe the solutions of the homogeneous equation ax equals 0 in parametric vector form. So what ax equals 0 is saying is that there's some matrix A and it's getting multiplied by some x, and in this case it's x1, x2, x3, and x4, and that simply equals 0. So we want to solve for x and put it in parametric vector form. Now that sounds scary, but all that means is that we want the solutions to be in terms of our free variables. Okay, the first step to do this is to row reduce A to get our solution. And I'm going to assume that you guys already know how to row reduce, so I'll give you the reduced row echelon form of the matrix. Okay, now that we have our reduced row echelon form, we can identify our free variables and begin our solution. So remember, free variables correspond to our non-pivot columns. And in this case, our pivot columns are the first column and the third column. So our free variables will be the second column here and this fourth column here. And remember that each column represents or corresponds to a variable. So this one is x1, x2, x3, and x4. So our free variables are going to be x2 and x4. And when we write our equation in terms of that, in terms of x2 and x4, all that means is that x2 and x4 are going to end up being on the right side of the equation. Okay, so let's go ahead and do this. The first step is to look at each row and see what it's telling you. So this row here is saying that 1x1 plus 3x2 plus 0x3 minus 6x4 equals 0 because it's a homogeneous system. And so since we want to solve in terms of our free variables, we want those to be on the right side of the equation. So I'm going to solve for x in this case, or x1. So x1 equals negative 3x2 plus 6x4. So now our free variables are on the right side. Okay, let's look at the second equation. This equation is saying 0x1, let me scroll up, plus 0x2 plus x3 and minus x4 equals 0. And again, we want x4 on the right side because it's the free variable. So we're going to solve for x3, which simply equals x4. So now that we have these two equations, we can start our process of writing the solution in parametric vector form. But before we start, it's important to understand that our free variables, x2 and x4, simply equal themselves. These are independent variables, and it doesn't matter what they are, so they simply equal themselves. Okay, now, the way that I like to write the parametric vector form is I like to start by writing out all my vectors, which in this case is x1, x2, x3, and x4, and that's going to equal some set of numbers, some vector times our first free variable, plus some other vector of coefficients times our second free variable. Because, like I said at the very beginning, our free variables are going to be on the right side, so I already know that. And regardless of how many free variables you have in your equation, just go ahead and write them out in this template. So plus whatever however many free variables you have in your problem. I like to do this and then go back and kind of fill in the template with the corresponding numbers. So in this case, this is saying that x1, we know that x1 equals negative 3x2, that's coming from here, plus 6x4. So we write them in the corresponding locations. The next one is x2, and we know that x2 simply equals itself. So we're going to give a coefficient of 1 for x2 and a coefficient of 0 for x4. Moving on to x3, x3 simply equals x4, so we're going to put it 0 for x2 and a coefficient of 1 because it simply equals x4. And x4 equals itself, so again another 0 for 2, x2, and a 1 for x4. And essentially, that is all you have to do to put your solution in parametric vector form. And since this is a homogeneous equation, these two vectors are the basis for your null space. And there you have it. I hope this helped you figure out how to write your solutions in parametric vector form.